Q.10 of May 2022, paper 1. This is section B. So consider the series ln of x plus p ln of x plus 1/3 ln of x. And consider the case where the series is geometric. So in part 1, we're asked to show that p is equal to plus or minus 1/3. So this is, again, fairly easy. So you just take the second term and the first term, divide that, and then set that equal to the third term divided by the second term, and you can solve for p, right? Hence, or otherwise, show that the series is convergent. Well, since the common ratio of this geometric series, is less than 1, right? We can deduce that the series is convergent, and so it therefore approaches infinity. I'm sorry, it doesn't approach infinity. It approaches a specific number as x approaches infinity, right? So given that p is greater than 0 and s infinite is equal to 3 plus radical 3, find the value of x. Okay, so we'll consider that the common ratio is positive, so it's positive 1/radical 3, and the infinite series is 3 plus radical 3, and we're asked to find the value of x. Okay, so lovely. Let's see, so the infinite series is u1 over 1 minus r, yeah, so u1, so we know that s infinite is, find the value of x, right? So we know that s infinite is 3 plus radical 3, right? And then 1 minus r is simply 1 minus 1/radical 3, and u1 is equal to ln of x. So you can go ahead and multiply with 3 plus radical 3 with 1. So 3 plus radical 3 minus 3 plus radical 3 over radical 3 equal to ln of x. So you can take common denominator here as well. So 3 radical 3 plus 3 minus 3 plus radical 3 over radical 3, right? Hopefully, yeah. Or, yeah, okay. So these will cancel out. You'll be left with ln of x. So 4 radical 3 over radical 3, the radical 3's will cancel out. No, it looks a bit fishy. Let me check. Yeah, where did I make a mistake? Yeah, so this, as I expected, this should be minus. Should be minus. Yeah, so here it should be minus. Okay, there we go. Now it makes sense. So this will be 2 radical 3 over radical 3, and so the radical 3's will cancel out, and ln of x will equal to 2. So x is simply equal to e to the power of 2. Now, I guess that's it for part A. Let me snip part B as well. Not sure if, okay, Mac lets me, okay. Okay, so now we're asked to consider the case where the series is arithmetic. And so let me write the series here as well. So it was ln of x plus ln of p plus p ln of x plus 1 over 3 ln of x. And then first part where I has to show that p equal to 2 over 3, so again just simply do p ln of x minus ln of x equal to 1 over 3 ln of x, right, because their common difference is equal minus p ln of x. So if you add both sides, it's going to be 2p. I guess you can cancel out the ln of x here as well. Simplifies things. So it's p minus 1 equal to 1 over 3 minus p. So 2p equal to 1 over 3 plus 1, or simply 4 over 3. So p will equal to 4 over 6, which is 2 over 3. Okay. Part 2, write down d in the form kln of x. D. So d is the common difference. So p ln of x, d is equal to p ln of x minus ln of x. So we know p is now 2 over 3 ln of x minus ln of x. So if you take the common denominator, it's going to be negative 1 over 3 ln of x. And so there you have it. You just wrote it in the form k ln of x. Now part 3, the sum of the first n terms of the series is ln of 1 over x cubed. Find the value of n. This is such a lovely question. It's a bit mind-boggling at first, but once you solve it, astonishing. Alright. So the sum of the first n terms, the equation of that is n over 2. So we don't have the term for un, so you have to use this 2 times u1 plus n minus 1 times d, because we want to solve for d. So I'm going to, before substituting in any values, I'm going to simplify the equation itself. So 2u1 n plus nd times n minus 1, so 2sn 2u1 n plus n squared d minus nd. And so if you treat it like a quadratic equation, it's going to be n squared d minus nd plus 2u1 n minus 2n is equal to 0. So now you can go ahead and substitute in your givens. So we know d is equal to negative 1 over 3 ln of x. So negative 1 over 3 ln of x n squared minus plus 1 over ln of x n plus 2 times u1, which is ln of x, so 2 ln of x n minus the sum of the series, which is, it's going to be 2 ln of 1 over x cubed equal to 0. So now what you want to do is you want to further simplify this by somehow getting rid of the ln of x. And you can do that by converting this. So this x has a power of negative 3. So you can, based on the parallel rule, you can take the negative 3 to the coefficient. So this really becomes plus, let me erase it, plus 6 ln of x. So now if you factor out the ln of x, you take it to the right side, you'll simply get rid of it. So you'll, in the end, you'll have negative 1 over 3 n squared plus 1 over 3 n plus 2n plus 6 equal to 0. And negative 1 over 3 n squared, 1 over 3 plus 2 is 7 over 3n plus 6 equal to 0, and you can factor out the negative 1 over 3. It's going to be n squared plus minus, right, minus 7 plus 18, or it's minus 18. And so if you factor that, it's going to be n minus 9 and plus 2 equal to 0, and since n must be positive, your only solution is n equal to 9. So hope that helps.